Hi, and welcome to the Mini Pallet Project. So this video will be in 4 parts, and the first part is going to be the hold down clamps and the heat treatment thereof, along with an introduction to the project as a whole. Part 2 will be the mini pallet for the mill, part 3 will be the mini pallet for the rotary table, and part 4 will be the overall review and feature listing and exploration of all the pallets themselves and some things I did maybe a little bit differently. It'll also include the drawings. So if you want to jump straight to part 4 and skip all the machining, feel free. I did try and abbreviate the machine to just the important bits. So I say we get to it. So this project will be a tedious one. I won't be showing you a video of all of it because everyone's seen a hole get tapped, and I have a bunch of them, probably close to 100 to tap. This project will be actually a pair of mini pallets, maybe even a third one. And I need to make these mini pallets to do the follow-up project where I'm going to be making a indexable internal chamfer tool for the lathe. And I need some way to hold them down on the milling machine with sacrificial material so that I won't damage the surface of the milling machine. So these are sort of a necessity, and besides, they're kind of a tool everyone needs to have. One of them is for the milling machine, and the other one is for the rotary table, which will be made for this rotary table. And that'll let me dial in angles on the milling machine. But we will be verifying those. So, without any further ado, let's get started. And I'm going to start sort of backwards. I'm going to start with the strap material, the straps that go on it, or the hold down clamps, whatever you want to call them. They'll be made out of A-tool steel, which I will be hardening. I'll be hardening it for toughness, not for hardness. So I'll be looking for maximum toughness because we want them to be strong. I'm not really worried about them abrading or something wearing them away or scratching them. So without any further ado, let's just get started. The first step is going to be, to make these, is to cut out the stock. And I have various sizes. I'm going to start with the smallest stock and see how it performs after it's hardened. So this is 1/8 by 5/8. I also have some 3/16 by 3/4. I also have some 1/8 by 3/4, and I also have 1/4 by 5/8. So I've got quite a variety. I think after these are hardened, they'll be strong enough because right now it's surprisingly strong steel. So I think after I harden it for toughness, it's going to be even better. Anyway, so I'm going to cut off a bunch of these pieces for, so I can get over and dimension them to final size and get started with the milling. So I finished dimensioning all the stock, but just to show you what I was doing, rather than show you all the boring details, I set my zero based on this stop for each of the different lengths of pieces, and just left as little sticking out as I possibly could. I'd cut one side leaving extra stock, then I'd open this and flip it and make sure it hits the zero well, and then take it down to size using the DRO since I knew this distance. DRO up there. One nice little feature that you've probably seen before, but in case you haven't, to keep the parallel space so you're not constantly fighting it, put a spring in between. It's a really handy little trick. Just keeps them squeezed against the side. Alright, so now we're going to move on to the next step, which is to mill the slots and drill and tap a hole. Okay, so here we are at setup number 3. The beauty of using this reference point is I don't have to find my zero again, and since the slots both start at the same spot, I don't even have to set my zero for the slot again. I can just go ahead and cut it. It's just a shorter distance. In this case, it's 0.657. So we're going to go. We'll do half in each pass. Oh, we got to get the speed back up again. Going about 1200 RPM. through. Be gentle when you're going through because milling bits are not really drill bits. So I've got to be gentle when I plunge. Okay, one down, one to go. I'll be back. And chamfer. Call that 0. Flip it over, rinse and repeat. Go to the same depth where I've set my 0. I'll come back to 0 on my x-axis. The last 10 thousandths are obviously, or 15 thousandths or so, are the toughest, so you go even slower because it's starting to engage more of the cutter as you reach both ends. And we're done. All right. So next step is drill and tap. So starting with the number 25 drill, tapping 1024. I'll bring you back for the next step, which will be after I drill through all of them, chamfer and then tap. Followed by chamfer and then tap. And I got a 0. That's it. See you back in a bit. So this next step, we're going to power tap. It's pretty hard material, but it's in its annealed state, even though it's tool steel, so hopefully it'll be all right. I've got my mill on the slowest setting, and hopefully if it gets stuck, the chuck will slip, which isn't good for the chuck, but better than breaking it off in the hole. There we go. All right, I'll finish the rest of these and I'll be right back. Okay, so here's my total kludge of a setup. So to put the 10 degrees angle on the end of this part, I have really jerry-rigged something because I don't actually have a part stop that mounts outside the vise. The only one I have is this traditional style that I made. So I really need to do that. I can't believe I don't have one. But so what I've done is I've got a sacrificial piece here that will be my stop for the parts. I take about 35 thousandths off to get a 10-degree angle on it. And they're spring loaded. There is a 10-degree, well, let me just swap out the part here, you can see. So there is a 10-degree, you can see it, angle block right here. And all I do is slide the part up carefully and gently until it reaches the stop. Then tighten. I'm running the mill really slowly, just taking off 35 thousandths. Which turns out might be a bit much in one bite, but we'll see. Going pretty gently here. And I think we're good. And we can move on to the next one. And that's it. See you after I'm done with this. So I decided to go a little deeper so I could have just a little more of the slope portion. It still leaves the edge thickness reasonable. Let's see if you can see it. There you go. So once this is heat treated and hardened, I think this will be plenty strong enough for the things I'm going to use it for. You're not going to really have really big, massive parts with deep cuts, so I think we should be good. The next step is to finish deburring this, clean it up, and heat treat. Alright, so the next step is going to be to take these guys and heat treat them. I think you should hear the sound they make before heat treating, and we'll compare it to after. So these are A2 tool steels, so I've got the kiln ready. First I have to put these in stainless steel wraps so the carbon doesn't come off the surface or get added, either way. And then we'll put it in the kiln, start the process. It slowly heats up, and when it gets to a temperature where after the slow heating the dimensions haven't changed too dramatically, then it goes up to austenizing temperature where it converts the material to austenite, and then that cools down. Then at that point you take it out of the kiln and you air cool it, and you cool it as rapidly using a fan down to around 100, 150 Fahrenheit. And after that, you throw it in tempering, and we're going to be tempering at about 525 degrees. I'm looking for maximum toughness and hardness combination. And then after it's been held there for 2 hours, then you pull it out, let it air cool, and should be ready to go. Alright, give me a moment to get some stainless steel wrap, and we'll move on. Alright, so here we are ready to put it in the kiln and start the kiln. I forgot to mention that I also had to clean all the parts and get all the oil and lube off it. I used alcohol. Acetone would be even better potentially. Anyways, let's go. Okay, so the parts are in. Closing the lid, and the kiln is starting. We're currently at 55 Fahrenheit, and we will slowly build up. I'll be back to pour it in later. Okay, so the austenizing process is over, and now it's time to retrieve the part and air cool it really quickly. There, it's glowing, and so we will be rapidly cooling it, quenching, and I'll be right back when we go to put it in to temper it. The tempering process takes 2 hours. So these are the parts after the austenizing process, getting ready to go back in for tempering. Alright, so here's the parts after heat treatment. I took Scotch-Brite to this one, and this is the original material, so you can see that it has changed color a little bit, and you can tell it rings differently too. So that's a cleaned up one. and the shrinkage was minimal, like A2 is famous for, so the 1024 threads still fit nicely. So now on to do the monotonous part and make the mini pallets.